questions 11 through 20 on the 2002 grade 10 AMC 10B. The product of three consecutive positive integers is 8 times their sum. What is the sum of their squares? So you got three positive consecutive integers, n plus 1, n plus 2. And their product, so you have to multiply them like that, is equal to 8 times their sum. So the sum obviously is you're just going to add them like this. And they want you eventually to find n plus 1, n plus 2, what is the numerical value, and then square them and add the sum. All right, so our first step is to find out what is n. So let's just do the algebra here. So we've got 8 times, let's see, 3n plus 3. So 8 times 3, because 3 can factor, n plus 1, like that. And then therefore this becomes n plus 1 is cancelable right there. So that just leaves n times n plus 2, which is 24. All right. And then at this point, you can probably do this by inspection. But if you can't, no problem. We'll just multiply it out. Put it all on one side and factor this. So let's see, n, 6, and 4. And then positive, negative, I think, yeah. So that means n is 4 or n is negative 6. But the question tells you that they're positive. So therefore, we only choose n equals 4. All right? So that means our numbers are 4, 5, and 6. Those are our three consecutive positive integers. Now they want you to find the sum of their squares. All right? So 4 squared is 16, 5 squared is 25, 6 squared is 36, and therefore that sum is 77. And therefore 11 is B. For which of the following values of k does the equation x minus 1 over x minus 2 equals x minus k over x minus 6 have no solution for x? So let's work with what they have given us, and let's see what we get. So the first step, cross multiply x minus 1, x minus 6, x minus k, and x minus 2, like that. So this gives x squared minus 6x minus x plus 6 is x squared minus 2x minus kx plus 2k. Correct? The x squareds go, and this looks like minus 7x plus 6 is equal to minus 2x minus kx plus 2k. So far so good, no mistakes. So minus 7x, bring the 2 over, 2x, and I guess bring all the x's over, so plus kx. And then over here you'll have 2k minus 6, like that. And this becomes minus 5x plus kx, 2k minus 6. And I guess we can factor out the x, so that will give you k minus 5, and then 2k minus 6. And then solve for x, or put everything on one side like this, k minus 5. All right? So that means once we get down to this, you can see hopefully that when k is equal to 5, this will be undefined. X is undefined, right? Because you can't have the denominator as 0. So k equals 5 will give you no real solutions for x. And that's pretty much what they're asking. For which of the following values of k does the equation have no solution for x? So k is 5 to get no solution for x. So 12, the answer is E. Find the value of x such that that expression is true for all values of y. All right, more algebra for us. minus 12y plus 2x minus 3. E is equal to 0. Okay. All right, where do we go from here? It's one of those questions where you sort of have to have a lot of practice. Not necessarily a lot of practice, but enough practice so that you know in confidence how to quickly approach this. I'm going to factor out a y because that seems kind of obvious to me. And let's see if that helps. All right, that does nothing for me, but I think I can factor out a 4 as well. That will be helpful. Yeah, there we go. Now this is definitely helpful. Now I can factor out 2x minus 3, and it'll be 4y, and it'll be 1, like that. Like if you put it in brackets, it looks a little bit more obvious. Okay, and that's it, I guess. So I guess 2x minus 3 is equal to 0, and therefore 2x is equal to 3, and x is equal to 3 over 2. So when x is equal to 3 over 2, this part becomes 0, and no matter what y is, it doesn't matter. This expression will be true. So when x is equal to 3 over 2, this is true for any value of y. And what is that? 13, 3 over 2 is d. Right here. The number 25 to the power of 64 times 64 to the power of 25 is the square of a positive integer n. In decimal representation, the sum of the digits of n is. So 25 to the power of 64 times 64 to the power of 25 is the square of some integer. So we have to first figure out n, and then we have to add up all the digits of n. All right? So for example, if n was some big long number, 5, 2, 8, 6, 5, whatever, right? We have to then add up the digits. So 5 plus 2 plus 8 plus 5 plus 2. You understand. So, okay, let's go with this. The first thing I notice is that the 25 is 5 squared. So, write it like that. And 64 is what? In lowest terms, the lowest base we can get is 2. 2 to the power of 6, and that's 25. All right? So, 2 times 64, 128. And then 2 is the base. 6 times 25 is 150. Is equal to n squared. Now we can take the square roots of both sides. Okay, so you're basically taking the square root of everything. And that leaves you with n. And then if you take the square root, you divide the exponent by half, right? So 128 divided by half is 64. And 150 divided by a half is 75. Okay, so now what? If we have the same exponents, we can combine them, but we don't. We have 64 and 75, but we can make them the same. We'll leave this one alone, but I'll make this one, I'll break it up into 64, and then what do we have left? 11, right? And then now, since the exponents are the same, we can combine them. So it'll be 5 times 2, all to the power of 64, times 2 to the power of 11, like that. And this becomes 10 to the power of 64, and I'll put 2 to the power of 11 over here, is n. And this is very helpful at this point, because now 2 to the power 11 is 2048 times 10 to the power of 64. Now 10 to the power of 64 is just 1, 0, 0, 0, like that, right? It just keeps on going for 64 zeros. So this basically becomes 2048 followed by 64 zeros, like that. And this is 64 zeros. That's what n is. That is the numerical value of n. Now they want you to add the digits. They want the sum of the digits. So it's 2 plus 0 plus 4 plus 8 plus 0, 0. But the zeros, who cares, right? Because they have no value. Like that. So the sum of the digits, you only have to worry about the actual numbers that are not 0. So 2, 4, and 8, so that's 14. And that's what they're asking for. The sum of the digits of n. So 14, that would mean 14. Number 14 is the answer is 14. So in letters, it's B. The positive integers a, b, a minus b, and a plus b are all prime numbers. The sum of these 4 primes is. Okay, so you've got a, b, a minus b, and a plus b, like that. And these are all prime numbers, and they want you to add them up and then look at the answer choices. All right, let's list some of the first primes. 2, 3, 5, 7, 11, 13. Let's see if we can do this by inspection. I hope. So let's see here. A minus b, a plus b. I think 5. 5, 2 on one side would be 3, 2 on the other side, 7. All right. So if 5 is a and b is 2, and this will work. A minus b will be 3, and a plus b is 7. Yeah, that'll work. So that means I've made all of those expressions prime numbers, and now they want the sum of these 4 primes. Well, the sum is 5 plus 2 plus 3 plus 7, and that is 17. All right, so now let's look at the answer choices. 17, is it even? No. Is it divisible by 3? No. Is it divisible by 5? No. Is it divisible by 7? No. Is it a prime? Yes, it is. So 15, the answer is E. For how many integers n is n over 20 minus n the square of an integer? All right. I guess we just have to do this by inspection. So let n equal, and then 0, 1, 2, 3, 4, 5, and so on, right? So what are we going to go up to here? I think the maximum n could possibly be is 20, right? Because if it's greater than 20, we're going to start getting negative values, and negative values can never be the square of an integer, right? So I'll prove that first before I get into all this stuff here. So let's say n was greater than 20, let's say it was 21. So that would become 21 over 20 minus 21. So this is 21 over negative 1, which is negative 21. Negative 21 can never be a square of an integer because a square of an integer is always a positive number. So we can never get over n equals 20. All right, so let's, whichever order, let's start with 0. If n is 0, we have 0 over 20, which is 0. Is 0 the square of an integer? Yeah, it is, because 0 squared equals 0. All right, so n equals 0 is one of our possibilities. Let's keep going. When it's 1, it's 1 over 19. When it's 2, it's 3 over 18. When it's 3, it's 2 over 18. Oh boy. 3 over 17, 4 over 16, 5 over 15, and so on. 6 over 14, 7 over 13, 8 over 12, 9 over 11, 10 over 10. 10 over 10 is 1. Is 1 the square of an integer? Indeed it is. So when n is equal to 10, we have 1, and 1 squared is equal to 1. So that 1 is the square of an integer. So now we have two values. We have 0 and 10. that give us the square of an integer for this expression. All right, let's keep going. For 11, it will be 11 over 9, 12 over 8, 13 over 7, 14 over 6, 15 over 5. But that's 3, and 3 is not the square of an integer. 16 over 4, which is 4, and 4 is the square of an integer. It's 2 squared. So that happens when n is equal to 16. All right, we're almost done. 17 over 3, 18 over 2, which is 9. 9 is the square of an integer. It's 3 squared, and that happens when n is equal to 18. 19 over 1, which is 19. 19 is not the square of an integer. And finally, 20 will give you an undefined because it'll make the denominator 0. All right, so how many did we get? How many values of n did we get that made that expression the square of an integer? We got 1, 2, 3, and 4. So 16, the answer is D. The regular octagon ABCDEFG has side length 2. Find the area of ADG. All right, first we need to draw an octagon. So here is an octagon, 8 sides of course, and they tell you that the sides have length 2, and therefore all the sides are 2. And they tell you that it's a regular octagon. Basically what that means is that all the sides are the same, like that. All right? And then we have to label it, of course, A, B, C, D, E, F, G, and H. And what do they want you to figure out? They want you to figure out the area of ADG. So A to D to G. That triangle is what they want you to figure out the area of. Okay? I think it'll help if I drop a perpendicular from A down to the bottom, and that will be our height, of course. Height, and then the base, of course, is GD. All right. Let's see what we can get from this diagram, and hopefully there's some symmetry here, which of course there is. Not perfectly drawn to scale, but that's okay. I'm going to draw that triangle in there, and that's going to help me, because if you take that triangle AH, this one, I'm going to draw it over on the side to avoid making the diagram more messy. So that triangle is like this, right? And we know that the hypotenuse is 2, correct? And what else do we know? We know that this is a right angle, okay? So this side is x, and because this is a regular octagon and there's symmetry here, this will also be x. All right? So therefore, you can easily use Pythagoras to figure out x. So we have 2x squared is equal to 4, x squared is equal to 2, and therefore x is equal to the square root of 2, like that. So that means that from here to here is square root of 2, and from here to here is also the square root of 2. Okay? Now from here to here is also identifiable because it's just 2. See that? And then from here to here is the same as this guy. So that's root 2. And then I think I'll need to draw one line to kind of illustrate. I'll draw a line from there to there. And you'll see that in a very similar way, right here, this distance is also root 2, because you can do the exact same calculation on the other side. And then this distance is the same as this guy, 2. All right? If I draw a line, hopefully this is supposed to kind of work out. Sorry, it's not drawn to scale, but you understand. So now we have everything we need to figure out the area of that red triangle. Area of the red triangle, which is ADG. this one, is 1/2 base times height. The base is this right here, which is root 2 plus 2 plus root 2, and the height is top to bottom like that, which is root 2 plus 2. All right, so let's do this here. We got 1/2 2 root 2 plus 2, and then root 2 plus 2. Before I multiply, I'll probably try to get rid of this half. If I multiply this by this, it'll just be root 2 plus 1, and then root 2 plus 2. And do they have anything like that? No, we have to multiply it all out. That's okay. Root 2 times root 2 is 2. Root 2 times 2 is 2 root 2. 1 times root 2 is just root 2 plus 2. So this becomes 4 plus 3 root 2. 4 plus 3 root 2, and that would mean 17 is C. Four distinct circles are drawn in a plane. What is the maximum number of points where at least 2 of the circles intersect? Okay, so 4 of them, right? So here's our first circle. Let's use different colors. Draw a second circle. So now we got 2 intersection points. Well, now we have to draw a third circle. Draw it in a way such that everything intersects. Okay, I think I did a good job there. And then one final circle in a way that it intersects everything. Oh boy, how do I do that? So I drew a blue circle that's slightly smaller than the red one because they say that all of them are distinct. All right, let's count those intersection points. We got 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Correct? Yeah, 12. Well, that was fun. I think that's it. I really don't know how you could possibly get 16. I don't think that's possible. So the answer to number 18 is D. Suppose that AN is an arithmetic sequence with A1, A2, all the way up to A100 is equal to 100. And A101 plus A102 all the way up to A200 is 200. What is the value of A2 minus A1? Okay, a little bit of a primer. If you're not familiar with arithmetic sequences, they are of the form A plus K, A plus 2K, A plus 3K, and so on. Okay, that is what is an arithmetic sequence. So for example, if A was, say, 10 and K was 3, you would have a sequence of the form 10, 13, 16, 19, and so on. Okay? That would be one arithmetic sequence. And what they want us to figure out, A2 minus A1, is basically this is the second term and this is the first term. So A2 minus A1 would be A plus K minus A, which is actually just K. That's it. So that is a little bit of a primer, just in case you didn't know. So now we have to use the 2 equations that they give us to somehow eventually find A and K. So here we go. The first one is A1 plus A2 all the way up to A100 is equal to 100. Okay, so the first one is just A, the second one is A plus K, and so on, all the way up till A plus 99K is equal to 100. Okay, so now we can add this up. There'll be 100 of those A's, right? And then you'll have K, but you can factor it out, and you'll get 1 plus 2 plus 3, all the way up till 99, like that. And that equals 100. Now, do you remember a formula for calculating the sum of consecutive integers? It's n times n plus 1 divided by 2. All right, where n is the last integer. So we can use that formula to quickly add those up. So that will be 99 times 99 plus 1 all over 2 is equal to 100. So this becomes 100a plus, it's 4,950, this guy right there, k, don't forget him, is equal to 100. And I think that's about as far as we can go with that guy. We'll call that equation 1. Okay, now let's go to the next one that they give us, which is A101 plus A102 all the way until A200 is equal to 200. Okay, so we have A101 plus A102 all the way up till A200 is equal to 200, like that. So A101 is A plus 100k, A102 is A plus 101k, and then you keep going all the way till A200, which is A plus 199k, is equal to 200. In a very similar way, add all this up. So how many will we have? We'll have 100 A's again. And then if you factor out a k, you'll get 100 all the way up till 199, 199, like that, is equal to 200. All right, so this sum is a little bit trickier. It's not consecutive starting with 1, but we can do that with the same formula, but this time we have to do a little bit of a subtraction. It's the sum of all the numbers from 1 to 199, which will be like this, and you subtract from that all the sum from 1 to 99, right? So that's 99 times 100 all over 2. So a little bit trickier, but I'm sure you understand that. And that equals 200. So this becomes, in the brackets, we have 19900 minus 4950, like that, is equal to 200. Let's move it all the way up. And this one becomes 100A plus 14950K equal to 200. And we call this equation 2. Correct? So we had equation 1 and equation 2. Equation 1 and equation 2 are very similar, which is good news. So I can use them to solve for k. And I immediately see that if I subtract one from the other, I will get rid of the a's. So 2 minus 1 would mean 100a plus 14950k minus 100a minus 4950k is equal to 200 minus 100, like that. So the a's go, and that leaves me with 10,000k is equal to 100, and therefore k is equal to 100 over 10,000, which is equal to 0.01. All right, so we got k. And then let's go back to the question. What do they want us to figure out? A2 minus A1. All right, so A2 minus A1. A2 is A plus K. A1, the very first term, is just A, and therefore this becomes just K. And K is 0.01. So that's the answer, 0.01, which would be choice C. Let A, B, and C be real numbers such that A minus 7B plus 8C is 4, and 8A minus plus 4b minus c is 7. Then a squared minus b squared plus c squared is. All right. So more algebra for us. So we'll write it out and see what we get. So this is our first equation, and this is our second equation, like this. All right. So what I want to do is get rid of one variable, and hopefully that will lead to us isolating one term for the other. So in these two equations, if I take equation 1 and add to it 8 times equation 2, I will be able to get rid of the c's. So that's a minus 7b plus 8c is 64a plus 32b minus 8c, and then we have 4 plus 56. All right, so we have 65a plus 25b, and indeed the c's go, equals 60. And we can probably divide through by 5. 13a plus 5b is equal to 12. And we'll try to get everything in terms of a. So we'll isolate for b in this equation. So we got 5b is equal to 12 minus 13a. And therefore b is equal to 12 minus 13a divided by 5. All right? So now let's try to eliminate another one. Let's eliminate b from these two. And we can do that in the same kind of way. Let's see, we have minus 7b and 4b, right? So multiply 1 by 4 and add to it 7 times 2. That should be able to get rid of the b's. So we got 4a minus 28b plus 32c, and then over on the other side, in terms of the other equation, we'll have 56a plus 28b minus 7c, and then the right sides become 16 plus 49. Okay, so indeed the b's go, so we are left with 60a plus 25c is equal to 65. So again, I think I can factor out a 5, divide through everything by 5, and that'll leave me with 12a plus 5c is equal to 13. And isolate for c, 13 minus 12a, and therefore c is 13 minus 12a over 5. All right, I've got everything in terms of a. Now we can proceed with what they want, which is a squared minus b squared plus c squared. A squared minus b squared plus c squared. So we have everything in terms of a. A squared minus b was 12 minus 13a over 5, all squared. And c is 13 minus 12a all over 5. Okay, what are our answer choices? Are they numbers or in letters? No, they're numbers. So somehow the a disappears, hopefully. All right, so a squared. All right, let's do this here carefully. Let's not mess this up. 144, 12 times 13 times 2, 312. And then 13 times 13, 169 positive. A squared. All over 25. All right. Again, let's do this carefully. 169, 12 times 13 times 2, minus 312. And 144, oops, forgot the a. A squared, all over 25. Okay. Let's see here. Let's put this guy first. 169 minus 312a plus 144a squared. And subtract from it this guy. Minus 144 minus 312, so it becomes plus 312a minus 169a squared. Okay, all over 25. Let's see how many things cancel. The 3 12s cancel. Anything else cancel? Nope. All right, 169 minus 144 is 25. 144 minus 169 is minus 25a squared. Okay. So a squared plus 25 over 25 is 1. And then minus 25 over 25 is minus a squared. And a squared minus a squared is 0, so this just leaves 1. Great. So the a's did indeed disappear. So this whole expression is equal to 1, and therefore the answer is 20 is B.